Okay, ji, assalamu alaikum. Hope so you will be all good and fine because the third wave is again now getting to its peak. So hope so everything and everybody is fine. Can you hear me? आवाज आ रही है जी? Can you hear me? आवाज आ रही है जी? Can you hear?
Yes, sir. Yes, sir.
Okay ji. Thank you. Okay, so the next topic is diode limiters or clipper circuits. Diode limiter, or these are also called clipper. Now, as we have seen in case of the half-wave rectifier circuit, so if we connect a diode in such a fashion that we have a resistor and then we have a diode connected in a circuit like this, and we are applying a sinusoidal waveform over here. And we are taking the output across the parallel combination of the diode as well as the resistor. And we say this is, let's suppose, resistor R1. So what is going to be the output if we consider the diode as an ideal diode? Anyone? If we say that the input is a sinusoidal waveform like this. So if I want to draw the output, how the output is going to look like? Anybody? जी, कोई idea? Okay, what is going to be the output if the diode is, if we have the positive half cycle? What is going to be the output? Anyone? पॉजिटिव हाफ साइकिल आएगी तो डायोड क्या होगा? Anyone? No idea? Oh, no answer. कुछ तो होगा ये, कुछ भी नहीं होगा. Okay, let's see. If we have the positive half cycle, so this means this side is positive, this side is negative, right? This means as this is the thing, so this means the current can flow in this direction, and then again the diode becomes forward bias, and when the diode becomes forward bias, the current will flow in this direction, right? Are you with me? बात समझ में आ रही है जी? Okay, so if this is the condition, so what is going to be the output? And we are taking the output across diode and the load resistor RL. And we are considering the diode as an ideal diode. So what does this mean? This means that in this specific case, the diode will be behaving as an ideal diode, and when it is behaving as an ideal diode, so this means during the positive half cycle, the diode will be behaving as a switch which is being a closed switch, right? And we have a load resistor RL. With that, we have the situation like this, that this end is positive, this end is negative, and we are taking the output across RL. This is our VI, right? So what is going to be the output? Anyone? जी आउटपुट क्या होगी? No idea. You can say something. As you can see, there is a switch which is being short circuited and a load resistor RL. So what is going to be the output? Across short circuit, what is going to be the voltage?
VI 0.
So when the switch is short circuited, this means there is going to be a 0 volt drop across the short circuit switch. The short circuit switch and the load resistor, they are in parallel. So this means we will be considering only the short circuit one, because there is a short circuit path. So all the current will flow through the short circuit path, and the voltage will be 0 across this, because the short circuit path is not offering any resistance. So this means for the positive half cycle, the output, when we are considering the diode as an ideal diode, so in that specific case, for the positive half cycle, we have 0 output, right? When the negative half cycle comes, means this portion, right? When the negative half cycle comes, what will happen? In that specific case, we can see when the negative half cycle comes, the diode will behave as an open switch, right? So this means This end is negative, this end is positive, right? And when this is the condition, so this means the current will flow in this direction. And because the diode is open switch, so this means the current will be flowing through this portion, right? And when it is flowing through this portion, so whatever the input we are applying over here, if we consider R1 very, very small than RL, so the output V naught in that specific case will be equal to Vi. So this means the output which we are taking it over here will be a negative half cycle. Are you with me? Question. बात समझ में आ रही है जी? Any question? Is this thing fine?
Yes, sir.
ठीक है जी. Okay. So now if we change the direction of the diode in the circuit, what will happen? Let's see. Now previously this was the direction. Now if we change the direction of the diode, so this means we have the resistance, and now we have the diode which is being connected in this direction. Again we have the load resistor RL, R1, and we are providing the input Vi over here, and we are taking the output across the parallel combination of a diode and that of the RL. Now what will happen? Again, when the positive half cycle comes, right? When the positive half cycle comes, we have Vi over here. Now what will happen? When the positive half cycle comes, this means this side is positive, this side is negative. And in that specific case, again, the diode will become reverse bias. When the diode will become reverse bias, so this means this will be behaving as an open switch. And when it is behaving as an open switch, so we can say that the situation is something like this. Vi, positive, negative, R1, RL, and the diode is behaving as an open switch. So and this means that the output will be across that of V naught, right? And this means the current will be flowing in this direction and it will be flowing through the resistor RL, right? So this means when the positive half cycle comes, the output V naught will be something like this. Again, if RL is very, very big than R1, or if it is not, then we can use the voltage divider rule, right? You know about voltage divider rule. पता है आपको? If it is not, then we can use the voltage divider rule. And voltage divider rule is V naught will be equal to RL divided by R1 plus RL into Vi, right? Are you with me?
Yes, sir.
ठीक है जी. So depending upon if RL is very, very big, so we will consider that the output is equal to input in that specific case. If it is not, then we can use the voltage divider rule and we can actually figure it out, the output value over here. right? When the negative half cycle comes, means this one. So in that specific case, what will happen? That the diode will behave as closed switch, right? And when it will behave like a closed switch, so this is this, and we can say that the direction of the current will be now this one, or this end is positive and this end is negative, right? And again, the output across the parallel combination of diode and the load resistor RL will be for the negative half cycle, it will be a flat out, right? Are you with me? Question.
No, sir.
Okay, so this is, I think so this was simple. Now let's see what will happen that when we put a biased or biasing inside. Okay, when we put a biasing or we have a biased limiter, this means that a DC source is added with that of a diode, and how the output is going to behave with the combination of a DC source with that of the diode. So now let's see. This means we are now looking at the biased limiter circuit. Okay, before going into that, the one which is actually providing the limitation in the positive direction is called positive limiter circuit, and the one which is providing the limitation or clipping in the negative direction is called negative limiter circuit, right? So one is the positive limiter circuit. This one is the positive limiter circuit, positive, because it is providing the limitation in the positive cycle. And the other one is the negative limiter circuit or negative clipper circuit, that it is clipping the negative cycle of the input source, right? Okay, now we have the circuit like this. Now we have a diode over here, and with the diode we are adding a DC source. And again we have the output, and we are providing the input over here as AC source. And we have R1, and we have a DC source which over here we call as V bias, right? And we are taking the output across the parallel combination of diode and V bias with that of RL. So we are taking the output. Okay. Now again, considering the diode as an ideal diode. So what is going to be the output now? Anyone? Anyone having any idea? Again, we are providing the input like this, Vi, with the positive half cycle. First, we are applying the positive half cycle. So this means we are applying the positive half cycle. When we are applying the positive half cycle, this end is positive, this end is negative, right? Now again, considering the diode as an ideal diode, so the circuit will look like for the positive half cycle. So for the positive half cycle, the diode will be behaving as a short circuit switch. Then we have the V bias. Then we have the RL, and we are providing the input over here with the positive and negative as the positive half cycle. R1, RL, and V bias. And we are taking the output across that of the RL, right? Now, when the input is being applied over here, so what happens that the input rises over here. And if we say V bias is a value which is less than the peak value of the input. So if we say this is the Vm and this is V bias. Are you with me?
Yes, sir.
So if you can see that if V bias is less than Vm. Vm is the peak value of the input, right? If V bias is less than Vm, then this means as long as we say, let's suppose the circuit over here, we say that point over here is A, right? Now, as the input is rising over here for the positive half cycle, the input is rising over here. And if the input is less than V bias, so this means at point A, the voltage is less than V bias. Are you with me? So as long as the point A is having a voltage less than V bias, the diode will remain in the off position. Are you with me? As long as the point A in the circuit is having voltage less than V bias, the diode will remain in the off position, or this means it is behaving as an open switch. When the input reaches the value equal to V bias, at that very instant, when we are considering the diode as an ideal diode, so the net drop across the diode will become equal to 0. And once the net drop across the diode will become equal to 0, so the diode will be getting from the off state to the on state. Are you getting it? बात समझ में आ रही है जी? What we are saying that if the, let me just redraw what I have said. I said that let's suppose this is the input voltage. Input voltage, and we say that this is V bias. This is Vn. When the input is rising over here, right? If the input is less than V bias over here, if the input is less than V bias, so this means the point A in the circuit is having voltage which is less than V bias. When point A is having voltage which is less than V bias, so this means the diode will remain in the off position, or the diode is not forward biased, right? Once the input voltage reaches the value equal to V bias, so at that very moment, when we are considering the diode as an ideal diode, so the net drop across the diode will become equal to 0, right? And once the net drop across the diode will become equal to 0, so the diode will have a transition from the off state to the on state. And once the diode have the transition from the off state to the on state, so this means that the switch will become closed. When the switch will become closed, so this means that at point A, the voltage is now equal to V bias. And once it is across that it is equal to V bias, so this means now V bias is in the circuit. Are you with me?
जी सर।
बात समझ में आ रही है जी?
जी सर।
So once the V bias is in the circuit, so when the voltage, input voltage rises above V bias, right? If the input voltage rises above V bias, so the output will be held at V bias, because now the V bias, which is in parallel to RL, is now playing its role. Because if there are two things and one is held at some value, so in the parallel combination that value will be there. You cannot actually overcome that value. So this means output will be held at V bias as long as the diode is in the on state. Are you with me?
Yes, sir.
So this means when we are drawing the output, so the output will be, for the positive half cycle, it will go up to this till V bias, and this means till V bias, the diode is now turned on. When the diode is turned on, as long as the diode remains in the on state, the output will be held at V bias. Once the value of the input reduces from V bias, so this means the value at point A, reduces from V bias. So when it reduces from V bias, so this means the diode, which was a closed switch, now it will become an open switch, right? So when this will become an open switch, so the output will just follow the input, right? And For the negative half cycle, the diode will remain open. And when the diode will remain open, so this means the output will be flowing across RL or here, like this. Are you with me? बात समझ में आ रही है?
जी सर।
Question? Question तो नहीं है जी.
नहीं सर।
ठीक है जी. So as long as the at point A the potential is equal to V bias, the output will be held at V bias. As long as the potential at point A reduces from V bias, the output will be following the input, right? So this is the whole thing. बात समझ में आई? And this is the case when we are considering the diode as an ideal diode, right? Now, what if we change the direction of the diode as well as the biasing potential in the circuit? So let's see what will happen. Now, we have circuit like this, and we have a diode whose direction is changed as well as the biasing potential V bias whose direction is also changed, and RL is the same, R1 is the same, and we have V bias over here, and we are providing the input. Now, what will happen? As you can see, the diode is being held to the negative side of the V bias, right? And the potential over here, we say point A. Now, what will happen? What is going to be the output? Again, we are saying that the input is Vi, which is a sinusoidal wave, right? And we are taking the output across RL. Okay, so how this circuit is going to behave? Anyone?
Open circuit for positive.
So for the positive half cycle, when the positive half cycle comes, as you can see, the diode is in this direction. So at point A, when the positive cycle comes, so this means the potential over here is not making the diode forward bias, right? Okay, ji? Because for the whole positive cycle, this point is being held at positive value, and this end is being held with the minus V bias value, right? So for whole of the positive cycle, the diode remains or it will behaving as an open switch, right? And when it is behaving as an open switch, so this means the circuit will be behaving something like this. We have switch which is open for all of the positive half cycle. So the output will be across RL, and this means the output B naught will be just following the input, and it will be something like this, right? And as long as we say that RL is very, very big than R1, so the impact of R1 will be negligible. And once that is negligible, so we can say the output is just following the input. Now, when the negative half cycle comes, so this means this end is now held at negative, this end is now held at positive. And when the negative half cycle comes, so this means we are now in this cycle, right? Now, when we are in this cycle, so again, this means this end is now positive. So V bias, as long as this V input is in the negative direction, is less than V bias, so the diode will remain as an open switch, right? Or what we say that the potential at point A is less than V bias in the negative direction, right? So if it is less than V bias in the negative direction, so this means the diode will remain as an open switch. But as the potential at point A, becomes equal to V bias. So this means at that very instant, we have a transition of the diode from the off state to the on state, right? So as the potential over here at point A becomes equal to V bias, so this means we have a transition from the off state to the on state of the diode, right? And once we have the transition from the off state to the on state, so this means if we say this is V bias, so when the potential reaches V bias, so then the V bias will be the value of the output. So because that now then the V bias will be playing its role, and the potential output potential won't be able to increase beyond V bias in the negative direction. So this means we will be having a V bias in the output like this. And when the input reduces from V bias, so this means the potential at point A reduces from V bias, so then we have the transition of the diode from the on to the off state, right? So if we say in this output that at the line which we have drawn with the V bias, so we can say during this side we have the off state of the diode, and on this side of the line we have the on state of the diode. Are you with me?
जी सर.
बात समझ में आ रही है?
जी
Right?
बिल्कुल.
Question?